In this series of lecture segments, we'll look at the Relational Data Model, or RDM, and its practical implementation in database tables, rows, columns, key values, and so forth. And we'll start by setting up and exploring a simple database example using MySQL. We'll use this small database example throughout the next few segments. Our example comprises data about a bakery's customers, products, and sales. And sales come in the form of receipts with line items on each receipt for the products that were bought. For instance, line item 1 might be a chocolate eclair and line item 2 a cherry pie. And we'll start with 4 text files of information, the first one of which is shown right up here. This is file customer.txt, and it has a row for each customer giving an ID, an integer number, and then a first and last name. There's a header line here and in the other files reminding you what each column represents. File receipt.txt has for each receipt a row giving a unique receipt number. No two receipts have the same number. The date of the receipt, and the ID of the customer to whom the receipt belongs. LineItem.txt has a row for each line item, giving the number of the receipt to which the line item belongs, its line number within the receipt, 1 if the line item is first in the receipt, 2 if it's second, and so on, and then a string code for the product purchased. And then finally, product.txt has for each product a unique code, as was used just now in lineitems.txt. And again, no two products have the same code. And we also have a flavor and a type or kind of product and a price. Now, note in particular the use of identifying ID numbers or strings to link together these data sets. For instance, each product has a string identifier that also appears in each line item that involves that product, and that connects the line item with the product information. Likewise, each receipt has a numerical ID that appears in the line items belonging to that receipt. So here's an in-lecture question, the first of our set here. To be sure you get the idea, what's another example of an ID in these files, other than the product ID and the receipt ID, and how is it used to link two files together? It's a fairly straightforward answer. So the answer here is that the customer text has an ID, as we mentioned, and it's used in receipt rows, of course, to link the receipt to the customer. The use of identifying ID numbers or strings will be a recurring theme throughout the course. Databases make heavy use of unique IDs to link data from different tables, and we'll be making database tables out of these text files very shortly. So to be sure you understand ID numbers, let's look at row 9 of receipt.txt. Get all the information related to that receipt. Who made the purchase? And what did she or he buy? Again, if you've thought through the answer, what you should have come up with is that customer 19, the purchaser, is, looking in the customer text here, Natasha Stens, and the products that are bought here are all those line items connected to receipt 12698. So we go to line items for 12698, and they turn out to be all together in the lineitem.txt file, although that's not necessarily guaranteed. And the products in question are a 51 app, 70R, and a 26 8x10. And if we go look in product text then, we can find that the 26 8x10 is a truffle cake, and the 51 app is an apple Danish, and the 70R is a raspberry cookie. So the receipt is to Natasha Stens, and for a apple Danish raspberry cookie and truffle cake. Now, note also that the files avoid duplication of information. For instance, receipt.txt doesn't give the first and last name of the customer for each receipt, even though this would appear on a physical receipt. Natasha, for instance, has several receipts. There's 19 there and another 19 here, for instance. But her name appears only once in customer.txt. Receipt.txt gives only an integer customer ID referencing the correct line in customer.txt. This way, if multiple receipts have the same customer, the name only appears once. Now, well-designed databases factor out common data into different tables, the way good code factors common operations into functions. This is termed normalization in database design. Now, the term has deeper theoretical meaning, but a good first approximation is factoring data into tables in such a way as to avoid any redundancies or repetitions. Question 3, something to think about regarding normalization. Apart from aesthetic elegance, why is this data factoring or normalization important? Is it mostly a matter of saving space? Think about it and make your best guess, and a hint, the answer is the same in many ways as for factoring code into functions. And what you might have come up with here is that saving space is relevant, but it's a relatively minor point. Disk may be slow, but disk space is cheaper than dirt. The main reason is to avoid inaccurate edits. Multiple copies of the same code or of the same data invite edits to only one copy while accidentally omitting other copies. If a customer's name needs updating, for instance, it's much better to do so once in customers.txt than possibly dozens of times for each receipt the customer has in receipts.txt, with the risk perhaps of missing one or more of those receipts. And then question 4, just to be really sure you understand how the bakery data works just this once, use the text files supplied to find out how many times David Calendar has made purchases, whether he ever purchased a strawberry cake, and what the receipt number was, if so. And in case it's not obvious, you might find the search facilities of a text editor useful for this question. So, assuming you hunted all that up and figured it out, the answer is that he has made purchases 11 times, and he purchased a strawberry cake just once on October 29, 2007. And that's receipt number 25906 in here. That indicates that. He's number 15, and the receipt has a line item which we can just search for. And 259 STR9 is in fact a strawberry cake. Now, was that tedious? You bet it was. And if I'd asked you for a complete list of all his purchases, you'd have been really irritated. But it was easy for me. I just pulled all that junk into a database and then used SQL. So let's see how to do that. Now, to follow what I'm doing in the lecture from here, you need to set up your MySQL server if you haven't already, and you need to run SQL commands on it. MySQL, like most serious databases, runs as a server program. And the details of configuring, starting, or stopping servers, also known as services on Windows or daemon processes under Unix, the details are beyond the scope of this lecture. You should do online reading relevant to whatever system you're using. But here is at least a brief overview of the main concepts. First, a server runs in the background without any user interface, textual or graphical, and it's generally automatically started when you boot your computer. You can start and stop them by hand, for instance by a control panel, administrative tools, and services under Windows 7. I'm briefly illustrating that here. There's the Windows services list, and MySQL is running on my machine somewhere down here. Yeah, right there. But again, it would look different on Unix or on a Mac. Servers accept connections from other programs called clients, but not directly from a user. Client programs may even connect to the server from other machines, for instance, from web browsers that connect to web servers across the internet. And when you download and install MySQL, you'll be guided by the wizard or documents through configuring the MySQL server, including setting up a root account and password on the server. You'll also get a simple text-based client called MySQL, which we'll discuss below. And if you download it, you can also get a GUI client called Workbench. You may also find other MySQL clients from third parties. So, to summarize, the MySQL server talks only to other programs, not to you. But its client programs will talk to you and in turn to the server. You run a client program, whether MySQL, Workbench, or some other, to work with the server, either on the same machine as the server or from another machine. Now, as we said a moment ago, MySQL offers two client programs as part of its standard download. The first runs under an MS or terminal command line window, and it's called MySQL. The use of MySQL to describe both the server and the client is a bit confusing. So we'll use MySQL for the client command line program and MySQL Server for the database server. MySQL, the client, lets you conduct a command line conversation with the server, and to run MySQL, you place the MySQL Server installations bin directory, which I've got up here as an example for Windows, in your execution or command path. And this bin directory includes, or should include, MySQL exe, right there. That's what it looks like under Microsoft MS Windows, or it's just MySQL on OS X or on Unix. Now, setting an execution path is done differently on different systems. In Windows, for instance, it's done by Control Panel, System, Advanced System Settings, Environment. You can do a quick internet search and it will yield many sites explaining how to do it for your particular operating system. Once you do have the path configured, however, you can start the system command line or terminal application and then run the command MySQL -u and a username. I'll use root, and you can as well if you configured a root account when you set up your MySQL client, and then -p to have it prompt you for a password. So MySQL will prompt you for a password, and you get this initial prompt. Now, if you are using a lab installation, you need a non-root account and a password supplied outside of Lecture. Upon successful login, you do get this welcoming screen and a command prompt. And then you type SQL and other commands at the prompt and get responses on screen. Now, the MySQL command is old-fashioned, but it's very standard. All DBMSs offer something similar. It's also simple and reliable. When a DBA, a database administrator, is up at 3 o'clock in the morning hosing down a database emergency, you can bet that they have a MySQL session or something comparable running. Almost all database management systems also offer a more modern GUI interface, and each of these is unique and non-standard. MySQL's GUI is the Workbench, and you should know how to use both the tried and true command client and whatever GUI du jour is offered by your DBMS. Most of the lectures, however, will use MySQL in this course. Now, I'm not going to make the lectures into an online user's manual. Read the MySQL manual, which is pretty good, for details. But I will walk you through some initial steps so you can see how these tools look and do a few asides on how they work in general, like the client-server structure that we just discussed. Follow along with these steps for both MySQL and Workbench, so you'll feel at least basically comfortable with each. Don't just watch, do the steps yourself. And if you hit glitches, email the TAs or me. Now we'll pick up in the next segment with the walkthrough of MySQL and of Workbench.